Our scientist for this week is Dr. Nargis Malvalvala. Hope I'm saying that right. A pioneer mom who loves puzzles, sports, the arts, and studying black holes. She loves puzzles, biking and squash, reading, political activism, and STEAM education. She wants to know, how can we better study objects in the universe that we can't see because they don't give off light? What can they tell us about how the universe works? She studies astrophysics. Astrophysics is the study of stars, planets, galaxies, and forces throughout the universe. Dr. Malvalvala builds and uses extremely sensitive lasers and mirrors to detect objects and waves in space. She studies things like gravitational waves, which are disturbances that are created when black holes collide. She played an important role in the very first observation of gravitational waves, which now help scientists to better measure dark objects like black holes. She also studies quantum mechanics, which is a type of physics, to help build better tools for studying the universe. Her path to science, drawn to the sciences. She was raised in Karachi, Pakistan. She was very energetic, active, and mouthy as a child, according to the adults around her. She played a lot of sports. At 10 or 11, she got to interact with the very first computers. She always liked math and science because it felt like there was a right answer. She later learned that in science, there is often not one right answer. Making room for the arts, she went to a school where you got tracked into either math and science, or arts and humanities, or economics and commerce. She had a knack for an interest in the maths and sciences, but didn't want to be so tracked. She knew she was going to stay in the sciences, but she loved the creative process that she sees in the arts and believes that it can make you a better scientist. Pushing through the challenges. She went to graduate school at MIT. Early on in graduate schools was very hard. She would sometimes wonder if she was going to make it academically. She failed her PhD candidacy exams many times before she passed. She kept pushing through, and it did get better. Searching for the unseeable. Once she had gained the skills she needed, she quickly rose to the ranks. She continued her training at California Institute of Technology, then got a faculty job at MIT and became an award-winning scientist driven to study the parts of the universe that are the hardest for us to see, like black holes. She was part of the research team that first detected gravitational waves, an incredible discovery. Going deeper, she found that there were other questions she needed to answer before she could build the tools she wanted to build. She started looking into quantum mechanics and expanding her research to solve these problems. At the same time, she was interested in STEAM education, breaking stereotypes and encouraging kids to study both art and science. Her advice: learn from the arts. Seeing the creative process of art can really inform the way we do science. For example, you may be inspired to think about how you can use materials in a different way, or how you can use geometry in a different way. Science is made better by creativity. Pushing through the challenges. Whether you fail an important test, or don't fit in, or encounter unexpected obstacles, sometimes you have to do what it takes to push through, because good things could be waiting on the other side. Find the best science for you. There are so many different routes you can take in science, and every science is different. Some are more creative, some don't have very much math, some are out in the field, some involve a lot of other people. If you know what you are curious about and you're willing to try, you can find a path that fits your strengths. And our final quote: All of education should be about thinking and problem solving of different kinds. It doesn't have to be about what you already know, it's about what you can know.